Recently, I've been reached out by Creality to test their new diode laser engraver, the Falcon 2. Since my last laser cut speaker project, which was 4 years ago, I've always wanted to get my hands on a laser engraving machine, so I'm excited to see what Creality can offer with the budget-friendly Falcon 2. The laser comes pre-assembled and well protected with many accessories included like the material sample kit, a honeycomb bed, razors for additional height, tools for assembly, laser safety goggles, an air assist pump for cleaner cuts, and even a rotary roller for engraving cylindrical objects. The laser module itself has a power of 22 watts and Creality claims it can cut through 15 millimeters of wood in a single pass. The frame can fit on most desks, making it a great option for hobbyists, and has a large working area of 400 by 415 millimeters. For extra safety using the laser, an emergency stop button and key lock are included. The laser can work at the highest speed of around 400 millimeters a second. The setup of the laser is close to none because you only need to screw in the legs, connect the air assist, and install the laser module, making sure the cables and the hose move freely. The laser module has built-in cooling fans, 3 warning lights for the air assist, fire detection, and lens contamination. The controls are straightforward with 4 arrow keys for positioning and a home button to bring the laser module to its 0 position when working from an SD card. An aluminum plate is placed to protect the workbench and the honeycomb bed goes on top. The 24-volt power supply can now be connected together with the included USB cable to connect to your computer. For the first laser test, I will use the sample piece of plywood, which is a bit warped, so these holders that I made on my Creality 3D printer will hold down the piece of plywood. The focus of the laser can now be adjusted manually using the provided stepped focusing tool. The laser module is lowered until it rests on the top step of the tool, which is for engraving, and the module is locked in place using the thumb screws. I loaded an engraving test on the laser cutting software using my laptop, which allows me to easily operate the laser and its settings. So after checking the position of the material, I start the engraving test. I accidentally moved the workpiece at the start, so the engraved squares shifted a bit on the bottom. When finished, we can see the different shades and depth being engraved depending on the speed and power being used. Because the engraving on wood produces smoke, I will use this enclosure that Creality has to offer. The enclosure comes disassembled with clear instructions and is placed over the engraver with the air hose and the cables passing through the installed grommets. The fan is underpowered for an enclosure of this size and runs on 5 volts, but it does help to remove the fumes. The placement of the fan is also not ideal because it gets blocked by the frame of the laser, reducing the airflow inside the enclosure. So I will replace the 5-volt fan with a more powerful 24-volt fan. I also printed a reducer for the exhaust hose and a fan guard on my Creality 3D printer. I will place the new fan in the middle of the enclosure right above the laser engraver for best airflow. With the fume collection working much better now, I use another sample piece of plywood to engrave and cut an image. The large viewing window also adds an extra layer of safety by filtering the blue diode laser light so you can observe the machine doing its work. This image turned out great with different shades and depth of the engraving. I'll now try this 4mm birch plywood to engrave and cut an image of one of my upcoming projects. The image turned out quite good, but because I set the cutting power slightly lower, the pieces didn't cut all the way through, but with a bit of sanding on the edges, the puzzle assembled nicely. I use this test grid to check the most optimal speed and power settings for each material, like this 4mm plywood. I then tried this intricate cut on a piece of oak veneer, which is quite thin, but the laser had no problems cutting out the smallest pieces. One more successful test on a plywood sample. As I wanted to see the limits of the Falcon 2 laser, I started with an 8mm thick softwood, which didn't cut all the way through on some parts, so I increased the power on a 10mm thick piece. The letters were cut out smoothly in a single pass, leaving a clean outline and very little, if not any, burning on the wood. I then placed a piece that is 15mm thick, which Creality claims the laser can still cut through. Surprisingly, it cut through the wood in a single pass, so I'll step it up to 18mm. As you can see, even the 18mm wood was cut in a single pass at 80mm a minute, leaving a fairly clean surface. As the laser still seems to be capable of cutting thicker wood, I tried it on a 20mm piece. Surprisingly, even this thickness of wood can be cut in a single pass at 60mm a minute without burning the edges too much. I then cut this logo with no issues, apart from a few letters being stuck on the imperfections of the wood. The sample pieces of felt were cut into these detailed designs with clean edges all around, thanks to the air assist. I then tried engraving this piece of stainless steel, which makes a nice color palette caused by the different temperatures of the surface of the steel. I engraved this image on the other side of the plate using different speeds and power to gain different colors. I then took my power bank and disassembled it to engrave the aluminum casing, as it is not safe to engrave plastics due to toxic fumes. The anodized aluminum is engraved with great detail and even curves nicely along the edges, though I could have aligned the case better to the frame of the laser. As diode lasers cannot cut or engrave transparent materials, I am applying a coat of black water-based paint on a piece of acrylic to see if it can be engraved. Once the paint is dry, I place it with the painted side facing down and focusing the laser on the surface of the paint, not the top of the acrylic. After washing off the paint, you can see the text engraved on the surface. I then tried coating this piece of glass with the same paint, but I wasn't expecting a decent result. To my surprise, the glass was etched with quite fine detail. I then wanted to try the rotary roller, so I removed the honeycomb bed, plugged one of the stepper motor connectors into the rotary roller, and used these riser extensions that I 3D printed to raise the machine. After aligning the rotary attachment to the frame and setting it up on the software, I placed this glass bottle for engraving and adjusted the focus of the laser module. My mistake of not placing the image correctly made it mirrored, but the etching of the glass still turned out fine. I then placed this glass for engraving, which turned out great with fine details engraved on the cylindrical surface of the glass. Engraving the steel bottle, which I believe is powder coated, didn't seem to work that well because it was causing burns, but after cleaning the set, the result of the engraving was quite pleasing. I then tried this tiny glass jar to see if the very small details are visible after engraving. Finally, I engraved the stainless steel flask after making sure the surface is level to the laser module. Though the setup of the rotary roller is quite tedious and time-consuming, it is a good quality tool attachment to the laser engraver to unlock its full potential for hobbyists or small businesses. Overall, I have to say that I am impressed with the capabilities, performance and features of this laser engraver. Considering the price and the fact that it fits on a desk, I think this is a powerful tool for any workshop. Link to the Creality Falcon 2 is in the description below. As I mentioned in the beginning of this video, my last laser cut speaker project was 4 years ago, so since then I wanted to make a better one. So for my first project using the laser, I designed this small portable speaker on Fusion 360, which I will split into layers that will be cut from 4mm plywood. So I exported the design into the laser engraver software and started cutting the frame pieces. It is important to use good quality laser plywood, which is made with different glue between the layers and cuts much smoother and leaves a nicer finish, unlike the regular birch plywood. I used a speed of 350mm a minute at 85% power for the best results. As the plywood sheets were not flat, some areas got slightly burned or didn't cut through because the laser becomes out of focus on spots that are bent. Overall, the cuts went really well with all the parts dropping out of their frames. I used the scrap pieces to cut the holders for the battery and electronics. With all the pieces cut out, I removed the smallest pieces with a knife and moved on to gluing the frame. I'm using regular PVA wood glue, making sure to spread it well on each layer. With all 14 layers glued together, I stacked the pieces for the battery holder. Once the speaker enclosure has dried, I sanded it smooth to remove the dark spots and reveal the plywood layers. I'm using 2 coats of water-based varnish for a semi-gloss finish. When the first coat is dry, I lightly sand the surface and apply the second coat. I'm now marking the position for the on-off switch and cutting the hole on the laser. The piece of tape helps to minimize any burning around the cut. For the speaker components, I will use these 40mm 5-watt speaker drivers, a passive radiator, a 10-watt Bluetooth amplifier, charging and voltage boost modules, a switch with a few other parts, and a high-capacity battery with a protection board. I start the wiring by soldering cables to the speakers. I am applying silicone adhesive around the edge of the speaker and gently placing it inside the enclosure. I'm using CA glue to attach the passive radiator with silicone adhesive around the edges to make the speaker airtight. I will now stick a strip of gasket tape around the back frame. For charging the speaker, I will use this magnetic USB socket that presses into the back panel tightly. A drop of CA glue will keep it in place and make sure it's airtight. I now insert the battery charging board and solder a red LED that will shut off when the speaker is fully charged. The battery holder and the frame for the PCBs can now be glued on the back panel. While the glue is drying, I will connect the battery protection board to the lithium-ion battery cell. For that, I will use my portable spot welder. A soldering iron can be used instead, but it is not recommended to expose the battery cell to high temperatures, which can even cause a fire hazard. With a strip of paper to isolate the side of the battery, I place and connect the battery protection board using the spot welder. I apply a drop of adhesive and insert the battery in the frame. The charging board can now be connected to the battery board. I now solder the output of the battery board to the voltage booster. The switch that I am using has 4 pins, 2 for the switch and 2 for the LED. Once installed, it is secured with a nut from the inside. We can now continue the wiring so that the voltage booster gets power when the switch is turned on. The switch lights up when turned on, and now the voltage of the booster module needs to be adjusted to 5 volts for the amplifier board by turning the potentiometer. I now insert and solder a capacitor to the power input of the amplifier. Just don't repeat my mistake by soldering the capacitor off to one side by one pin, which I only noticed and fixed later off camera. The output of the voltage booster can now be connected to the amplifier. All that's left is to connect the left and right speaker wires and tidy some of the wiring to reduce rattling once closed. I use these small screws to secure the back panel. With the rubber feet glued on the bottom, the speaker build is finished. The speaker can now be charged using the magnetic USB cable. I think the speaker turned out even better than I was expecting. It is lightweight, easily portable, and connects to your device instantly. The battery lasts for around 16 hours on a high volume, and the speaker has crisp sound quality. Thanks to Creality for making this project possible. Links to the laser engraver, parts, and build plans are in the description. I will leave you with a few audio samples, so thanks for watching and I'll see you on the next project.